Welcome to another exercise in this workbook, Statistics. This time I'm going to focus on measures of dispersion. So our task here is the following data set, which summarizes the age of students in a university lecture. And this is those 12 observations. Our tasks in regard to this data set are first off determine the range, interquartile range, the corrected variance, and finally the corrected standard deviation. So to make part A and B a bit easier, I'm going to start with reordering this data set. So I'm going to copy this, then I'm going to order this in an ascending fashion, meaning I'm going to start with the smallest values, always increasing these values. So I have a data set arranged from smallest to largest value by the end. This is something I need to easily do part A and B, so the range and the interquartile range. Because for the range, I simply go with the difference between maximum and minimum. Maximum being the largest, minimum being the smallest value, or if I have an ordered data set, maximum being the last value, minimum being the first value of the data set. So here I'm calculating 30 minus 20, which gives me 10 as the range of my data set. So the age of the student spends a total of 10 years. That was already part A. Part B is similar in the calculation. So here I'm going to use the same ordered data set, but for the interquartile range, I have to calculate the difference between third and first quartile. So the 75% percentile and the 25% percentile. Those values I'm going to calculate in the following way. I'm going to multiply 0.75 with the number of observations and 0.25 with the number of observations. So if I do this, I get 9 and 3. However, 9 and 3 are integers. So in those cases, I'm going to do something different than you might have seen in different other sessions. I'm not going to round up anything. If I have calculated the 9, so for the first value, for my third quartile, I'm going to take the 9th value and take the average of 9th and 10th value. So here, observation 9, observation 10, I'm going to take the average of those two. That's my third quartile. For the first quartile, where I got 3 as a result, I'm going to take the third and the fourth observation and calculate the average of those two. So here I get 28, that's those two averaged, 28 minus 20.5. This gives me my end result of 7.5 for the interquartile range. Well, that was already the second part. That's also the part where I actually needed an ordered data set. The other two parts I could also do with the unordered data set, but those two really profit from having the data set ordered, so that I can easily look up like third largest, fourth largest value or something similar. Well, let's continue with the variance and the standard deviation. So first part I need here to calculate the corrected variance is the arithmetic mean. This I can easily get by simply adding up all values and dividing them by the number of observations. So here I get 24.5. Then I have two different ways of calculating my corrected variance. The first one would be take each value, subtract the average, square the result and add all of this up, divide this by the number of observations minus 1. Or a bit less error prone is the version we're going to use here, which follows this formula, which at the beginning might look a bit more complicated, but what we're going to do here is just take the square of all of these observations, so going 20 to the power of 2 plus 20 to the power of 2 plus 20 to the power of 2 plus 21 to the power of 2, so forth, adding all of them up. Once we added all of them up, we're going to divide them by the number of observations minus 1. So here we have 12 observations, so we're going to divide this end result, this sum, by 11. Let's have a look here. So that's actually adding up all these squared values. Then I'm going to divide this by 11. That's the first part. Then I go minus. Then I have number of observations divided by number of observations minus 1. So 12 observations divided by 12 minus 1. So I have 12 divided by 11. That's this part. Then finally I'm going to multiply this term, this correction term, with the squared mean. Mean was 24.5, so I'm going to multiply this with 24.5 squared. Putting all of this in my calculator will yield me the result of 14.4545, which then is my end result for my corrected variance. Corrected since I'm using here n-1 and I'm using here this correction factor of n divided by n-1. Well, since we have the variance, it's an easy step to also get the corrected standard deviation, which is nothing else than simply using the variance we calculated before and getting the square root thereof. So here we're taking the square root of 14.4545, giving us a standard deviation of 3.8019, which then is the last part we had to do for this exercise, which brings us to the end of this part. So I hope you enjoyed it, I hope you learned something from it, and I say goodbye and see you next time.